What if I told you there's a dormant superpower buried inside your brain right now? A survival system so powerful that it can eliminate hunger, supercharge your immune system, and potentially reverse diseases that modern medicine says are incurable. And here's the thing, you've had it your entire life. Every human does, but almost nobody knows it exists. This pathway was forged 67 million years ago when an asteroid slammed into Earth and turned our planet into a frozen wasteland. The mammals that survived that extinction event developed something extraordinary, a biological override switch that allowed them to thrive in conditions that should have killed them. And that switch, it's still inside you, hardwired into your hypothalamus, waiting to be activated. But there's a catch. Modern life has buried this pathway so deep that most humans will never access it. We've been living in artificial summer for so long that we've forgotten winter even exists. Stick around until the end, because I'm going to show you exactly how this pathway works, the science behind it, and why some researchers believe it could be the key to reversing obesity, diabetes, and even aging itself. And I'll give you my take on what this means for your health. Let's pull back the curtain. To understand what I'm about to share with you, I need to tell you about a neurosurgeon from New York City who stumbled onto something that changed his entire understanding of human biology. His name is Dr. Jack Kruse, and in 2007 he was in trouble. He was a successful spine surgeon, but he was also morbidly obese. We're talking about a man who weighed over 350 pounds. He had high blood pressure. He was pre-diabetic. He was on the fast track to an early grave, and he knew it. So he did what any scientist would do. He started digging into the research, not the mainstream diet advice that clearly wasn't working. He went deeper. He started reading papers on leptin, on circadian biology, on evolutionary medicine. He became obsessed with one question. Why are humans so sick when we have more medical knowledge than ever before? What he discovered sent him down a rabbit hole that would consume the next decade of his life. He found that there's an ancient metabolic pathway buried in the hypothalamus, a pathway that most doctors don't know exists, a pathway that evolution designed for survival in extreme conditions. And he believed that reactivating this pathway was the key to reversing modern disease. He tested it on himself first. He lost over 130 pounds in less than a year. His blood markers normalized, his energy skyrocketed, and he did it without counting calories or spending hours in the gym. Then he started writing about it. He published a series of blog posts called the Cold Thermogenesis Protocol. And what he laid out in those posts is some of the most fascinating and controversial health information I've ever encountered. Today, I want to break down his ideas for you, because whether you agree with everything he says or not, the science he's pointing to deserves serious attention. Before we dive into the biochemistry, let me show you why this matters with a real-world example. In 2011, a Dutch man named Wim Hof walked into a research laboratory and let doctors inject him with bacterial endotoxins. These are the same toxins that cause severe sepsis, the kind of infection that kills people in hospitals every single day. The researchers expected him to get violently ill. That's what happens to everyone else. But Wim Hof didn't get sick, not even a little bit. His body produced a massive surge of cortisol that neutralized the toxins completely. The doctors were stunned. They had no explanation for what they witnessed. Here's where things get interesting. Wim Hof isn't a genetic freak. He's not superhuman. He's a guy who spent years training in extreme cold, ice baths, swimming under frozen lakes, climbing mountains in shorts. And somehow, that cold exposure unlocked something inside him that the rest of us have forgotten we possess. Dr. Kruse would say that Wim Hof accidentally stumbled onto the ancient pathway. He activated a dormant survival system through years of cold exposure, and the results speak for themselves. The question is, what exactly is this pathway and how does it work? Deep inside your brain, there's a region called the hypothalamus. Think of it as your body's master control center. It regulates your temperature, your hunger, your sleep, your hormones, pretty much everything that keeps you alive. And buried within the hypothalamus is something called the leptin-melanocortin pathway. This is what Dr. Kruse calls the ancient pathway. Now, most people have heard of leptin. It's often called the satiety hormone because it tells your brain when you've had enough to eat. But according to Kruse, that's actually the least interesting thing leptin does. Here's what the textbooks don't tell you. Leptin is primarily a cold-based electron counter. It evolved to help mammals survive in freezing environments where food was scarce, and death was always one bad decision away. When this pathway is fully activated, something remarkable happens. Your body stops craving food. Your immune system goes into overdrive. Your metabolism shifts into a fat-burning mode that makes you radiate heat like a furnace. And your brain releases a cascade of hormones that make you feel more alert, more focused, and more alive than you've ever felt. Dr. Kruse points to the Sherpas of the Himalayas as living proof. They eat pure butter and lard at high altitude and somehow maintain incredible strength and endurance. NASA studied them extensively in the 1970s. They wanted to understand how these people could perform superhuman feats with minimal food and oxygen. What they discovered supports everything Kruse has been saying about cold adaptation. So how does this pathway actually get activated? This is where Dr. Kruse's work gets really fascinating. According to his research, your body has two completely different metabolic operating systems. Think of them like two different modes on your phone. There's the warm adapted mode, which is what most of us run on all the time. And there's the cold adapted mode, which is the ancient pathway. The switch between these two modes happens in your eyes and your skin. Your suprachiasmatic nucleus, that's the part of your brain that controls your circadian rhythm, normally takes its cues from light. When the sun comes up, certain hormones rise. When it goes down, others take over. This is how your body knows what time it is and what season you're in. But here's what Kruse calls the metabolic trap door. When your skin temperature drops to around 50 to 55 degrees Fahrenheit for an extended period, something extraordinary happens. Your body releases a chemical called endothelial nitric oxide synthase, and this chemical does something that sounds almost impossible. It disconnects your circadian clock from light and reconnects it to temperature. Let me say that again because it's important. Cold exposure literally rewires how your brain perceives time and seasons. Once this switch flips, your hypothalamus stops expecting carbohydrates. It stops craving sugar. It shifts into a mode where fat becomes your primary fuel source, and your body starts burning calories as pure heat instead of storing them. This is why people who are cold adapted can eat enormous amounts of food without gaining weight. Michael Phelps famously ate 12,000 calories a day during his Olympic training. Everyone thought he was burning it off through exercise, but he was training in cold water for hours every day. His body was literally radiating those calories as heat. One of the most remarkable claims Dr. Kruse makes is about what cold adaptation does to hunger. And I mean, he says it destroys hunger in a way that seems almost supernatural. Here's the biochemistry he lays out. When you're cold adapted, leptin gets released from your fat cells in massive quantities. We're talking about levels that dwarf what happens under normal conditions. This leptin floods into your brain and binds to receptors in your hypothalamus. Now, normally there's a hormone called neuropeptide Y that drives your carbohydrate cravings. It's the thing that makes you want bread and pasta and sugar. When leptin binds to its receptors in cold conditions, it completely shuts down neuropeptide Y production. But it doesn't stop there. Cold also suppresses something called agouti-related peptide, which is another hunger signal. And it does this through a clever mechanism involving calcium channels. The cold receptors in your skin use calcium to send their signals. When they're constantly firing, they essentially hijack the calcium that a goodie needs to function. The result? You can go hours, even days, without feeling hungry. Not through willpower, not through discipline, through biology. This is exactly what happens to hibernating mammals. Bears don't wake up in the middle of winter desperate for a snack. Their ancient pathway is fully activated, and hunger simply doesn't exist for them during that time. Kruse argues that the same pathway exists in you. It's just been dormant because you've never given it the signal to activate. Remember Wim Hof and those bacterial toxins? Dr. Kruse's framework explains exactly what happened in his body. When the ancient pathway is activated, your hypothalamus produces large amounts of a protein called POMC. This protein gets cleaved into two incredibly important hormones, alpha MSH and ACTH. Alpha MSH is one of the most powerful immune modulators in your body. It reduces inflammation across your entire system. It's why cold-adapted people tend to have darker skin, by the way. Alpha MSH stimulates melanin production, but the real magic is in ACTH. This hormone tells your adrenal glands to produce cortisol, and not just a little cortisol. We're talking about a massive controlled surge that supercharges your immune response. This is exactly what the researchers saw in Wim Hof. His cortisol levels spiked to levels they'd never seen before, and it neutralized the bacterial toxins before they could make him sick. Here's what Kruse finds profound about this. Modern medicine treats high cortisol as a problem. Chronic stress produces cortisol, and chronic cortisol destroys your health. But acute controlled cortisol release in response to cold is completely different. It's protective. It's healing. The ancient pathway doesn't just help you survive cold. It arms your immune system for battle. Now here's something from Dr. Kruse's work that challenges everything you've been told about weight loss. The conventional wisdom says you can't get rid of fat cells. You can only shrink them. When you diet, your fat cells get smaller, but they're still there, waiting to fill back up the moment you slip. Kruse says this is actually true, but only in warm-adapted humans. In cold-adapted humans, something different happens. Fat cells die. He points to research from 2008 at Massachusetts General Hospital. Scientists were studying children who had gotten frostbite on their faces. When these kids healed, the fat in their cheeks was gone. Not shrunk. Gone. The cold had triggered a process called apoptosis, which is programmed cell death, specifically in their fat cells. The researchers realized they could use controlled cold to permanently eliminate fat tissue. This eventually became a procedure called cool sculpting, which is now a billion-dollar industry. But here's what Kruse emphasizes: you don't need a machine to do this. Your body has this capability built in. When leptin is released in large quantities during cold exposure, it doesn't just signal your brain. It also triggers apoptosis in white adipose tissue. Your fat cells literally commit suicide. At the same time, cold exposure stimulates the conversion of white fat into brown fat. Brown fat is metabolically active. It burns calories to produce heat. Babies are born with lots of brown fat, which is why they can regulate their temperature without shivering. Adults lose most of their brown fat because we live in climate-controlled environments. Cold brings it back. To really understand why this pathway exists, Dr. Kruse takes us back 67 million years. When that asteroid hit the Yucatan Peninsula, it didn't just kill the dinosaurs. It fundamentally changed the conditions for life on Earth. The impact threw so much debris into the atmosphere that it blocked out the sun. Temperatures plummeted. Photosynthesis stopped. The food chain collapsed. The mammals that survived this extinction event weren't the biggest or the strongest. They were the ones who could adapt to cold and scarcity. Kruse makes an important point here. Evolution doesn't waste energy maintaining systems that aren't useful. The fact that this ancient pathway still exists in every mammal on Earth, including you, tells us something important. It's been activated many times throughout our evolutionary history. Ice ages, volcanic winters, periods of extreme climate change. Here's what he finds fascinating. 90% of all life on Earth right now lives in cold environments. The deep ocean, the polar regions, the high mountains, cold is actually the norm for life on this planet. We're the weird ones living in our heated houses and air-conditioned offices. Our genes don't know we've conquered winter. Our DNA still carries the programming from ancestors who had to survive brutal conditions without any of our modern conveniences. And here's something else Kruse emphasizes. Because evolution has been speeding up over time, epigenetic changes happen faster now than they did millions of years ago. This means the mismatch between our ancient genes and our modern environment is creating problems at an accelerating rate. Obesity, diabetes, heart disease, autoimmune conditions. These aren't random diseases. They're the result of running warm-adapted software on hardware that was designed for cold. This is where Dr. Kruse's ideas get really controversial, and I want you to really think about what he's proposing. What if type 2 diabetes isn't actually a disease? I know that sounds crazy. Diabetes kills people, it destroys organs. It's one of the biggest health crises in the modern world. But consider what Kruse points out. Insulin resistance is exactly what happens to mammals preparing for hibernation. In the fall, when carbohydrates are abundant, animals eat as much as they can. They become insulin resistant. They pack on fat. Their blood sugar stays elevated. This isn't a malfunction, it's a feature. It's how their bodies prepare for months of cold and scarcity. The problem, according to Kruse, is that for modern humans, winter never comes. We eat carbohydrates year-round. We live in heated environments. We never give our bodies the signal that it's time to burn off that stored fat and reset our insulin sensitivity. The ancient pathway is the reset button. When mammals emerge from hibernation in spring, they're lean. Their insulin sensitivity is restored. Their metabolic health is optimal. This is why cold exposure has such dramatic effects on blood sugar regulation. It's not treating a disease. It's completing a cycle that our bodies expect but never receive. Kruse points to the Inuit people as evidence. They lived this way for thousands of years. They ate a high-fat diet, experienced brutal cold, and had virtually no diabetes or heart disease. Then modern civilization arrived with heated homes and year-round access to carbohydrates. Within 2 generations, they developed all the same metabolic diseases as everyone else. The environment changed. Their genes didn't. There's another piece too, Dr. Kruse's framework that most people completely miss. And it has to do with when you eat, not just what you eat. Your body runs on a 24-hour clock. Hormones rise and fall in predictable patterns. Cortisol peaks in the morning to wake you up. Leptin rises at night to signal your fat stores. Growth hormone surges during deep sleep to repair your tissues. When you eat outside of these natural windows, you create inflammation. Your body gets confused signals. Your circadian clock falls out of sync with your metabolism. Here's something Kruse says that will blow your mind. Eating a banana in December if you live in a cold climate creates inflammation in your brain. Why? Because your hypothalamus knows that bananas don't grow in winter. When it detects tropical fruit during what should be a cold season, it interprets this as a mismatch. And mismatches create stress responses. This isn't about the banana being unhealthy. Bananas are fine in summer. It's about the timing being wrong for your biology. The ancient pathway synchronizes your eating patterns with the seasons. When it's activated, you naturally stop craving foods that shouldn't be available. Your appetite aligns with what your ancestors would have had access to. This is why cold-adapted people report that their food cravings change dramatically. They stop wanting sugar and carbohydrates. They start craving fat and protein. Their bodies are finally getting accurate information about what season it is. Let's talk about what happens when elite athletes tap into this pathway. Dr. Kruse brings up Lance Armstrong. Whatever you think about his doping scandal, there's something else going on that nobody talks about. He trained in cold. He had freezers installed in his house with stationary bikes inside them. His training regimen was closely guarded, but people who worked with him reported that cold exposure was central to everything he did. And here's the thing about Lance Armstrong that Kruse finds even more remarkable than his cycling victories. He beat metastatic testicular cancer that had spread to his brain. The prognosis for that is usually death. He didn't just survive, he came back and dominated his sport. Coincidence? Kruse doesn't think so. The ancient pathway supercharges your immune system. It increases growth hormone. It optimizes cellular repair. These are exactly the things you'd want if you were fighting cancer. The Sherpas demonstrate something similar. NASA measured their metabolic rates and found they were 400 to 500% higher than the climbers they were guiding. They could eat pure fat at high altitude and maintain incredible strength. Their VO2 max, which is the measure of how efficiently your body uses oxygen, was off the charts. These aren't genetic freaks, they're humans who live in the ancient pathway because their environment demands it. The same capability exists in you. It just needs to be awakened. One of the most surprising effects Dr. Kruse describes is what cold adaptation does to pain. When the ancient pathway is fully activated, your sensitivity to pain drops dramatically. This isn't just numbness from cold. It's a fundamental change in how your nervous system processes pain signals. The mechanism involves those same alpha MSH hormones I mentioned earlier. They don't just boost your immune system, they also modulate pain perception at the spinal cord level. Kruse mentions documented cases of surgeries being performed on cold-adapted individuals with minimal or no anesthesia. The patients reported feeling pressure but not pain. Their recovery times were dramatically faster than normal. This makes evolutionary sense. If you're a mammal surviving in a harsh winter environment, you can't afford to be incapacitated by every injury. You need to keep moving, keep hunting, keep surviving. The ancient pathway includes built-in pain management. Chronic pain patients who implement cold exposure protocols often report significant relief. Not because the cold is numbing them, but because it's activating systems that reduce inflammation and change how their brains process pain signals. This is the same reason that ice is the first thing we reach for when we get injured. We intuitively know that cold helps with pain. We just didn't realize how deep that connection goes. In 2009, Elizabeth Blackburn won the Nobel Prize for her work on telomeres. These are the protective caps on the ends of your chromosomes, kind of like the plastic tips on shoelaces. Every time your cells divide, your telomeres get a little shorter. When they get too short, the cell dies or becomes dysfunctional. Telomere length is one of the best predictors of biological aging. Short telomeres are associated with every disease of aging you can think of. Heart disease, cancer, dementia, the works. Here's what Dr. Kruse finds remarkable. Cold exposure appears to protect and even lengthen telomeres. The mechanism has to do with something called reactive oxygen species or free radicals. These are byproducts of metabolism that damage your cells and shorten your telomeres. The more efficiently your mitochondria burn fuel, the fewer free radicals they produce. When you're cold adapted and burning fat, your mitochondria become incredibly efficient. They produce less waste, less cellular damage, less telomere shortening. This is why animals that hibernate live longer than their body size would predict. They spend months in a state of reduced metabolism with minimal oxidative stress. Their telomeres are protected. Kruse points to the Himalayan monks who live at high altitude in cold conditions. They routinely live past 100. They eat very little. They meditate in freezing temperatures. And they maintain cognitive function and physical capability that would be remarkable for someone decades younger. They're not doing anything magical. They're just living in alignment with the ancient pathway that evolution designed for longevity. So if this pathway is so beneficial, why don't more people know about it? Why isn't this mainstream medicine? Dr. Kruse has some thoughts on this, and they're uncomfortable. We've built an entire civilization around avoiding the very stimulus that activates our optimal health. Central heating, air conditioning, warm clothing, hot showers. We've engineered cold out of our lives so completely that most people have never experienced what their bodies are actually capable of. And here's the thing, the research exists. NASA has studied this. The Russian Olympic program has used cold training for decades. Elite athletes around the world are implementing these protocols. But there's no money in telling people to take cold showers. You can't patent ice water. The pharmaceutical industry has no incentive to fund research that might make their products unnecessary. Meanwhile, we have 60 million diabetics in America alone. Heart disease is the #1 killer. Obesity rates are climbing every year. Children are developing diseases that used to only appear in the elderly. We're running warm-adapted software on cold-adapted hardware, and the system is crashing. The ancient pathway isn't alternative medicine. It isn't a fad. It's the operating system your body was designed to run on. We've just forgotten how to boot it up. So how do you actually activate this pathway? Dr. Kruse has laid out a detailed protocol, and the good news is, it's simpler than you might think. The key is consistent cold exposure that brings your skin temperature down to that 50 to 55 degree range. This is cold enough to activate the surface receptors, but not so cold that you're in danger of hypothermia. Kruse emphasizes that you don't start by jumping into an ice bath. That's a recipe for shock and failure. You start with your face. The face has the highest density of cold receptors on your body. Dunking your face in cold water for 30 seconds at a time begins the adaptation process. From there, you progress to cold showers. Start with just the last 30 seconds of your shower being cold. Gradually increase the duration over weeks. Eventually, you can work up to full immersion in cold water. A bathtub with ice, a cold plunge pool, a natural body of cold water if you have access to one. Kruse says the adaptation takes about 2 weeks for the initial changes to occur. But the full benefits develop over months and even years. He mentions that it takes 24 to 36 months to reach peak adaptation. During this process, your diet matters. Seafood becomes incredibly important because of the omega-3 fatty acids. Your cell membranes need to become more fluid to function properly in cold, and omega-3s make that possible. You'll also want to avoid eating within a few hours of your cold exposure, and pay attention to the seasons. Eating tropical fruits in winter while trying to cold adapt sends mixed signals to your hypothalamus. So let me bring this all together. Dr. Jack Kruse has spent over a decade researching and writing about a survival system that evolution spent millions of years perfecting. A system buried inside your hypothalamus that can eliminate hunger, supercharge your immune system, burn fat while you sleep, reduce pain, and potentially add years to your life. The biochemistry he points to is documented. The pathways are mapped. The results are visible in everyone from Himalayan Sherpas to Olympic athletes to ordinary people who've discovered what their bodies are truly capable of. The ancient pathway exists because our ancestors needed it to survive, and it still exists because evolution doesn't discard tools that work. Modern life has buried this pathway under layers of comfort and convenience. We've traded our biological birthright for climate control and year-round access to tropical fruit. But the pathway is still there, waiting. All it needs is the right signal. Cold is that signal. You don't need expensive equipment. You don't need a doctor's prescription. You don't need anyone's permission. You just need the willingness to be uncomfortable for a few minutes a day. If you want to dive deeper into Dr. Kruse's work, I'll link his blog and his cold thermogenesis series in the description below. It's dense reading, but it's worth it. What do you think? Have you experimented with cold exposure? Drop your experiences in the comments below. And if you want more deep dives into the hidden systems that control your health, hit that subscribe button. Until next time, stay curious.